On August 15, 1977, Jerry Eman was using Ohio State University's Big Ear radio telescope. It is a radio signal detector that at the time was pointed at a group of stars called Psi in constellation Sagittarius. When scanning the skies around the stars, Eman captured a 72-second burst of radio waves. Decoding the binary, the signal was saying "wow." It came to be known as the wow signal. Curiously, the signal was picked up by only one of the scope's two detectors. When the second detector covered the same patch of sky 3 minutes later, it heard nothing. This indicated either the unlikely possibility that the first beam had detected something that was not there, or the source of signal was shut off or redirected in the intervening time. The Big Ear maintained its periodic scan of that part of space for almost 40 years and never again came across that compelling signal. It was dismantled in 1998 to make way for a golf course. Wow remains the strongest and clearest signal ever received from an unknown source in space, as well as the most fascinating and unexplainable. According to hypotheses of well-known scientists such as Winston Churchill, Carl Sagan, and Stephen Hawking, it should be improbable for life not to exist somewhere other than Earth. This argument is embodied in the Copernican principle, which states that Earth does not occupy a unique position in the universe, and it can also be implied from the very vast size of the universe. The chemistry of life may have begun shortly after the Big Bang, 13.8 billion years ago, during the habitable epoch, when the universe was only 10 to 17 billion years old. Life may have emerged independently at many places throughout the universe, or alternatively, it may have formed less frequently but spread by meteoroids through the habitable worlds. Since 1950s, scientists have proposed habitable zones around stars where it is most likely to find life. Planets in the habitable zone have suitable temperatures to sustain liquid water, essential key ingredient to life. This narrow zone is also termed as the Goldilocks zone. In 1961, Frank Drake devised the Drake equation. It is a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way. It looks like this. N is the number of civilizations. R is the average rate of star formation in a galaxy. F subscript P is the fraction of stars having planets. N subscript E is the average number of planets that can potentially support life. F subscript I is the fraction of planets that actually support life. F subscript I the fraction of planets with life that evolves to become intelligent. F subscript C is the fraction of civilizations that develop a technology to broadcast detectable signals of their existence into space. L is the length of time over which such civilizations would broadcast detectable signals. Based on observations from the Hubble Space Telescope, there are 125 to 250 billion galaxies in the observable universe. Estimated 10% of all Sun-like stars have system of planets, and 1 in billion stars have planets supporting life. There should be more than 6 billion life-supporting planetary systems in the observable universe. Yet we have no evidence of them except, of course, a short radio burst, which still doesn't hold enough evidence to conclude it was artificial, not a natural phenomenon. The question arises, where is everybody? This contradiction between theory and what is practically observed is said to be the Fermi paradox. No one has a solution to this paradox, yet we have developed ideas and hypotheses as to what is stopping us from contacting aliens. On cosmic scales, humans are extremely new. If we were to compact the time scale of evolution of universe to 24 hours, humans will come in just the very last second. But yet, in that 1 second, humans have advanced from hunter-gatherers to launching rockets and sending humans to moon, probing other planets, and wondering about our own origin. In fact, there is no reason not to believe that there must be other, much older, and technologically advanced civilizations out there. The technological advancement of a species is measured by a scale called the Kardashev scale. Its rating goes from 1 to 3. A Type 1 civilization would be able to access the whole energy available on the planet. In case you are wondering, we are 0.73 on the scale and will reach Type 1 civilization in the next couple hundred years. Type 2 would be a civilization capable of harnessing all the energy of its home star. Concepts like the Dyson sphere, a giant complex surrounding a star, would be conceivable. A Type 3 civilization would basically control its whole galaxy and its energy. An alien race this advanced would be godlike to us. If they build spaceships which travel even at 0.1% the speed of light, they would still be able to colonize the entire Milky Way galaxy in just 2 million years, just an instant on the cosmic time scale. If there are millions, if not billions, of planets sustaining life, Milky Way galaxy should be colonized by now. Many scientists hypothesize a great filter. A filter in this context represents a barrier that is really hard for life to overcome. They come in various degrees of scary. If there were great filters and we have passed them, then maybe it is way hard for complex life to develop than we think, and conditions required may be really complicated, or maybe in the past universe was way more hostile and only recently have things cooled down to make complex life possible. This would mean that we may be unique, or at least one of the first, if not the first civilization in the entire universe. Secondly, there may be a great filter ahead of us. Maybe life on our level exists everywhere in the universe, but it gets destroyed when it reaches a certain point, a point that lies ahead of us. For example, awesome future technologies exist, but when activated, it destroys the planet. If this is true, we are closer to the end than the beginning of human existence. Maybe there is something out there we better not discover. Or maybe we are alone, a tiny mote of dust in the cosmic ocean. Maybe we are the only life universe has. We are the first and last of our kind. We are all the universe has in name of life. If this is the case, it is a sole duty to help prevent the extinction of life, to colonize planets, venture out of a warm, cozy Mother Earth into the vastness of space, in name of continuation of life, and become a multi-planet species. We must be highly careful though, because if we are alone, there is nobody to save us from ourselves.